Well, hello, and welcome back to the channel. It is Tuesday, February 17, 2026. Can you believe it's already mid-February? Time flies when you're just a voice in a box, talking to, well, mostly yourself, I suppose. Hey, I know you're out there listening. Today, I have dug up something really fascinating from the archives. It's a paper that tackles a problem we didn't even know we had until recently. It's about teaching AI to forget, but making sure it stays forgotten, even when we shrink the AI down to fit on your phone. The title is Quantization-Robust LLM Unlearning via Low-Rank Adaptation. The crow is, it's long, but don't worry, I'm going to break it down for you. So let's dive into the meat of this paper. Imagine you have a super smart AI with a large language model, or sometimes these models learn things they shouldn't. Maybe it's private information like someone's phone number. Or maybe it's copyrighted material, like the entire text of a Harry Potter book. You need a way to make the AI forget the specific information without making it stupid at everything else. This process is called machine learning. Now, here's the tricky part. To run these huge AI models on everyday devices like your laptop or a smartphone, you often use a technique called quantization. Think of quantization like lowering the resolution of a photo. You take a high-definition image and mark it a bit more. In AI terms, we reduce the precision of the numbers inside the model, usually from 16-bit down to 4-bit. It makes the model much faster and lighter. But here's the problem this paper identifies. When you teach an AI to forget something using standard methods, the changes to the model's internal brain weights are actually very tiny. There are subtle adjustments. So when you later apply quantization pixelation previous, those tiny adjustments get rounded off. They disappear. It's like writing a secret message in very faint pencil, and then someone comes along and photocopies it in high contrast black and white. The faint pencil marks just vanish. The result? The AI suddenly remembers the secret information. You try to make it forget. It reverts back to its old self. Scary, right? So this paper proposes a solution using something called LoRA, or Low-Rank Adaptation. Instead of trying to slightly match the entire massive brain of the AI, LoRA adds a small, separate, trainable module on top of the frozen brain. It concentrates all the forgetting effort into this small, intense adapter, because the changes in this adapter are much stronger and more focused. They survive the quantization process. Let's talk about how this applies to real life. Why should we care about robust encoding? First, think about big habits in dialogue systems. These are the programs we talk to for customer service or just for fun. If a company finds out their accidentally memorized a user's credit card number from a previous conversation, they need to delete the knowledge immediately. If they update the model to forget it, but then compress the model to run on a full app, standard methods might fail, and the bot could still leak their credit card number. This paper's method ensures the bot keeps that secret forgotten, even on a mobile device. Second, consider machine translation. These are tools that automatically translate between languages. Sometimes translation models learn biases and offensive phrases from the internet data they were trained on. If developers try to unlearn these offensive translations, they want to make sure the model doesn't suddenly start spewing them out again, just because the model was optimized for a smaller server. This technology keeps the translation clean and safe, regardless of how compressed the model is. Third, let's look at information extraction and text summarization. These tools write massive amounts of documents to find key facts. Imagine a legal AI that summarizes court cases. If a judge orders that a specific piece of evidence must be stricken from the record and forgotten for privacy reasons, the AI must comply. If the AI is then deployed to a lawyer's tablet in a compressed format, it must absolutely not be able to be called as stricken evidence. This paper ensures that legal compliance holds up, even in low-reserve environments. The researchers tested this on the Llama 2.7 model, using a benchmark called News. They looked at books and news articles. The results were pretty impressive. Standard methods failed hard when the model was squeezed down to 4-bit prohibition utility dropped, and the secrets leaked back out. But with the LoRA method, privacy leakage dropped significantly. The example in the book dataset, the privacy leakage score went from a terrible 25.68 to a much better 5.86, which is way closer to zero, the ideal score. And it did this by keeping the model smart enough to answer other questions correctly. So in summary, this paper solves the amnesia reversal problem. It proves that if you want an AI to truly forget something, you want to run that AI on a normal computer. You can't just gently suggest it. You'd have to use a strong, concentrated adapter like LoRA to make sure the memory is wiped for good. It's kind of like... alright. Reminds me of that time I tried to teach my goldfish to play fetch. I thought he learned it, but then I realized he just forgot he was a fish. Wait, that doesn't make sense. Anyway. Unlearning is hard. That's it for today's deep dive. Let me know in the comments if you trust your AI to keep a secret. Until next time, this is Nino, signing off.